Now we are looking at cosine x and sine x, and the region bounded by x equal to 0 and x equals to pi over 4. Our goal is to rotate this about x-axis. So what's the visualization look like? Let's take a look at our sine function, cosine function. X is bounded between 0 and pi over 4. So the sine function at 0 is equal to 1. And then it hit x-axis at pi over 2, right? Here we go. For cosine function, this is the behavior of cosine function. So let's write it down, cosine of x. What about sine? Sine at 0 is equal to 0, and it is 1 when x is pi over 2. These two functions intersecting at pi over 4. At pi over 4, they have the exact same value. Remember that cosine x is equal to sine x in the first quadrant, x is equal to pi over 4. Both of these have the same y value, which is square root of 2 divided by 2. Very good. So let us go back here. We know that x is equal to pi over 4. So we already have that vertical line, right? The other piece is x is equal to 0, which is our y-axis. So we look at this portion of the graph. We try to rotate this portion of the graph with respect to x-axis. So let us erase unnecessary portions and start rotating this about x-axis. Very good. So basically, if we continue this here to have a nicer shape, this is our x, cosine x, and this is our object, which is rotated about x-axis. So we look at a cross section. A typical cross section is just located here, right? So how do we find the area bounded between these two? If we look at the larger area and the smaller area, because as you can see, one portion is located on cosine and the other portion is located on sine. So the larger area minus the smaller area can be calculated this way. The larger area is pi r squared, and the smaller area is pi r of x squared. But this r is located on cosine. So this is pi cosine squared of x minus the smaller area is on sine. You can see it right here. Pi sine squared. Okay, so let's go back to our volume. The volume formula is the definite integral of the larger area minus the definite integral of smaller area, which we can combine as pi of cosine squared of x minus pi of sine squared of x dx. Well, what are the boundaries here? My x ranges between 0 and pi over 4. I know that. This is given in the question to me. My x ranges between 0 to pi over 4. So the lower bound is 0 and the upper bound is pi over 4. I'll write it a little bit nicer. So the volume is the definite integral 0 to pi over 4. You can factor out pi, write it outside. You get cosine squared of x minus sine squared of x dx. Remember that from pre-calculus, cosine of 2x was cosine squared of x minus sine squared of x. But we have this guy just right here. We can simplify this using pre-calculus formulas and techniques that we learned. So v is equal to the pi 0 to pi over 4 of cosine of 2x dx. Now in taking the integral of cosine 2x, we are using u sub the integral of cosine 2x dx. If u is equal to 2x, du is 2 dx, or dx is du divided by 2. This guy is equal to a half sine of 2x plus c. This is another formula that we're going to use in our calculation. So again, pre-calculus, and now we are using calculus. So v is equal to pi over 2 of sine of 2x, x ranges between 0 and pi over 4. So the volume is equal to pi over 2 sine of 2 times pi over 4 minus sine of 0. But know that sine 0 is equal to 0. You end up with v to be pi over 2 times 1, or pi over 2. To get an approximation for the volume, you can use a calculator.